Yes, graphical relationships. I have two graphs here. You should figure out which one is f of x and which one is fe of x. That is the derivative graph. I can only recommend that you also take a look at the overview I made. I'll also label them with f, fi, and f double prime, and actually you should be able to get through it easily. It also helps with understanding for curve analysis. So, what should you recognize here? Actually, you can already see the shape of the graph drawn here in black. We have a maximum point here, an inflection point here, and a minimum point here. Let's take a look at the graph here. It has a minimum point, so we have two extrema here and one extremum here. That's actually already the first clue that when you differentiate, something gets reduced. So maybe that's already the first clue. Then the connection. What happens at a maximum or minimum point? I know that at a maximum or minimum point, the slope is 0, so we have a horizontal tangent. Those are also expressions like if it doesn't say, please determine a possible extremum point, but rather look where the graph of the function would have a horizontal tangent along its course. That's the hint. The slope must be 0 here. So if the derivative graph is drawn to show, hey, that gives you the value of the slope, then you can see here 0, 0. That means we have f of x here and accordingly f prime of x here. I'll write that down here now so you can see, okay, that's the connection. Now I can move down here. Yeah? Maximum, minimum, extremum. In the original function, that is a 0 of the first derivative. That's why you set f prime of x equal to 0 as a necessary criterion to even find potential extrema. What do we have at the inflection point? At the inflection point, we have a change here, in this case, from concave down to concave up. What do we know? We know, or as you already know, to check for an inflection point, you set the second derivative to 0. Why is that? I'll try to draw that again in a moment, the graph for the second derivative. First, you know, okay, what is happening here before the maximum point? There, the graph of the first derivative is above 0. Why? Because I'm climbing up the hill. Then the slope is 0. Then I go down the hill. That's why the derivative graph is below 0 here. Then the slope is 0. Then the derivative graph is above 0 because I'm climbing up the hill again.